The issue with this tail recursive factorial, well, there's two issues, but we're only going to discuss one in this video. The issue is that now the the user of this factTR method now has to give an accumulator to this method. Why should the programmer be, or the user, the caller of this method, why should they be given the responsibility of passing an accumulator? Well, they shouldn't, right? The accumulator is only important in the context of this tail recursive factorial method, right? Because of that, there's no need to expose it to the user. I keep saying programmer, but to the person who just wants to compute the factorial of some natural number. There's no reason that they should be able to pass an accumulator and, just in a reliance of good faith, I guess, have the user always pass 1. Because the user could pass 5 for all they know, and of course this test case is going to fail, but that's sort of the issue here, right? The user, the caller of factTR, should not know about what an accumulator is. It should only do what it's supposed to do. Just compute the factorial of a number, which just so happens to be tail recursive. So we're going to get rid of these things here because we want this to look exactly the same as our standard recursive tests. When you're writing test cases for standard versus tail recursion, these should look identical, with the only difference being the method name. So whenever we ask you to write a standard recursive and a tail recursive version of the same method, you should always have the same exact test cases for both methods. And the only difference should be the invocation name, the method name. But now the issue is, well, what are we going to do about that accumulator? We need the accumulator. You're right, we do need the accumulator. What we're going to do is we're going to write what's called a driver method. We're going to write a method that jump starts the tail recursive algorithm. Okay, so we're going to call this static int factTR, and it's just going to receive the same arguments as our standard recursive version. And in fact, you could just copy this and then just add tr to it. Okay. Now, we should also note that tr doesn't mean anything in the context of Java. It's just an annotation or a suffix that we've given to say that, yeah, this method is tail recursive. If you're writing real-world code, you wouldn't do that. But just for pedagogical purposes, that's what we've done. Okay. Now we're going to move this Java doc up here. Okay. Well, actually, we're not going to move it. We're just going to, we can copy it, get rid of the accumulator, and now all we have to do is just call this recursive helper method using the starting value of the accumulator. Okay? Now, while we could leave the method name the same, I think it's better to always suffix it with like helper or something like that. Because really what this method is doing is it's actually running the tail recursive algorithm that we care about. Right? This method just jump starts the recursion, or the tail recursion. But the programmer or the user of this doesn't necessarily need to know that or care about that. They only care about computing the factorial of an integer or a natural number. Okay? So let's do that. How do we do that? Well, we're going to do return, and then we're just going to call factTR helper with the value of n, and then our accumulator. Okay? That's all you have to do. Now, if we do this, all of our tests will pass. But there's one more subtle issue. The user can still call factTR helper and pass in something that's incorrect. And that's not good. We don't want that. We don't want the user to be able to call this helper method whose sole purpose is just, or rather, we don't want people to call this helper method because it has this accumulator that we don't want to expose to the user or to the person calling this method. So how do we do that? We're going to introduce something called an access modifier. An access modifier basically says, where can we access something? And as we'll see later in the class, we can extend this to variables. But for now, we want to say that this factr helper method can only be accessed within this file, within the context of this factorial class. Okay? And for our purposes, a class is just a location for methods. So we're going to affix the private keyword, where this means that this method, factr helper, can only ever be called in the context of this file, of this class. And indeed, when we do that, we're going to get an error here saying that this method has private access in factorial. Okay? And that's good. We want that. We don't want to expose the helper method to the tester. Okay? So what have we done here? We've created a driver method, we've created the helper method, which is private, and then we've tested the driver. Okay? You must always put private in front of your helper methods. If you don't, you will lose points on assignments. It is very important to not expose this to the caller of the driver method.